Okay, I'm going to try to answer three different questions here. Number one, is the original expression for Windchill linear? And the second thing is, if we put an f of v equals in front of the Windchill expression, we get a function, and the question is that function linear? And the last one is, if we put an f of t equals in front of the Windchill expression, does that give a linear equation? Let's look at the first question first. If I look at this expression for w, that's a constant times t. So far it's linear, right? Now I have minus 35.75 times v to the 0.16. Whoops, that v to the 1.6 right there, that makes w not linear. Because linear expressions can only have constants, and constants times a single variable. That's it. So this thing here, we really didn't care about this, but I think it was good practice to look at it. This is not linear. Now, how does putting an f of v in front of it change it? It now says, when they tell me this, they're telling me that v is the only variable and every other letter stands for a constant. So what I'm going to do is just put a little green box around everything that should be regarded as a constant. So there's a constant. Here is a constant because it has no v's in it. Here's a constant because it has no v's in it. Here's a constant because it has no v's in it. Now, this is going to be a linear equation if all I have are constants and constants times a single variable. There's a constant, there's a constant, there's a constant. Unfortunately, while that has a variable in it, it's not just a variable, right? So this thing right here tells us that f of v is not linear. All right, let's contrast that with the thing at the end. Let's put an f of t in front of it. Now I'm going to do the same thing I did before. I'm going to put a little box around everything that's a constant. This right here actually is a constant. The number next to t is a constant. Remember that t is the variable, so the t is not a constant. Let's put that t, make sure we don't lose it. This whole piece right here is now a constant because the only thing that can vary is t. This thing is a constant. This thing is a constant. Now, is what I have linear? What I have is a constant plus a constant times t. So far that's linear because that's what linear functions can look like. It can be a constant plus a constant times the variable plus another constant. We're still good. Plus, remember, these two things together are a constant. So what this looks like is a constant plus a constant times t plus a constant times t. That's linear. So the answer is yes. And in the little room I have left, we're going to try to write this as, something like y equals mx plus b. What I'm going to do is group everything that has a t in it together and pull out a t. Let's see, that has a t in it, and I'm going to pull it out, so I have 0.6215. Let's see, over here I have plus 0.4275, 0.4275, and I get v to the 0.16. And remember, that's a constant because t is the variable in this problem. Now I can pull out that t, right? So all I did was group together the things that had a t, and now what I want to do is group together the things that don't have a t. So there's the, let's see here, plus 35.74. What else doesn't have a t? Minus 35.74 v to the 0.16. All right. So all the things that had a t, I grouped together and pulled out a t. Everything that didn't have a t, I put right here. And what we just did is we rewrote this huge expression as a constant. Let's call that constant m because that's what we usually do. Yes, plus a constant. So in this case, All of this is M. All of this is B. And that's the whole problem.